Okay, Assalamualaikum, very good morning. Testing, 1, 2, 3. Can you hear my mic?
Waalaikumsalam.
Boleh.
Boleh.
Ya, boleh.
Clear, clear. Okay, right. Share my screen. Okay, Assalamualaikum, very good morning to all students. So basically, this morning we have 1 hour, 1 hour of class, and then for tomorrow is public holiday, so we have class. But if you look at our teaching plan, just open teaching plan. Okay, the teaching plan is also in the ULearn. This one. So if you look at the teaching plan, we are at week 3. So we are still at the set user chapter 2, and by next week we are going to go to the signal conditioning, right? So basically, I actually covered until this topic 3 topic, which is the sensors. We already did the exercise 3, which is exercise 2 is basically to do research, a bit of a background on types of sensors. So this is what you did on looking at the different types of sensor: displacement sensor, position sensor, velocity sensor, force sensor, pressure sensor, and so on. Okay. So, and exercise 2 was on you are given an application, example of a project. Okay, so you need to find out what type of sensor which is relevant to measure the output there. So basically for today is that I'm going to discuss on the exercises that you submitted. Then after that you're going to do the quiz self-evaluation. Okay, bear in mind is that for student, why most of the chapters that we are going to go through, chapter 1 and chapter 8, is that I'm going to give you MCQ question, which is the multiple choice question, because in the midterm exam, same types of question will be asked, means that same format, MCQ type question and objective question. So this is for you to familiarize. So if you did get marks during the self-assessment for chapter 1, chapter 2, means that you need to read more. Okay, so basically what you need to do today, this morning, is okay, before that, is there any background noise when I speak?
Instructor.
No.
Yes.
Oh, there's a background noise.
Ada berdesing sikit.
Pada sikit.
Suara doktor berdesing sikit. Jadi sakit
My
sikit.
voice ke ataupun ada background bunyi kipas?
Kipas tak ada.
Kipas tak ada, okay, tak apa. Kalau tak ada kipas, okay, because I'm using a different headphone yang biasa di office. Okay, anyway, this morning, as usual, what you need to do is that take attendance. Hopefully you have done that. And then for today is that we are going to directly discuss on exercises. So how we are going to discuss the exercises is not that I'm going to share the solution directly, but what I'm going to do is that I will ask a student in a group. It means that basically student need to have some volunteers to ask the question. Okay, to present their group assignment pass. So based on that, we are going to go directly to exercise 3. Okay, exercise 1, what you did was you were given the segment, okay, you're given the types of terminology and explanation, and I saw that most of the students did well based on the data sheet given. So basically, what was this task about is that, okay, when you are required to actually purchase a system to design something, okay, you need to design a mechatronic system. So basically, you need to measure an output, okay, and the output, sometimes types of output that commonly measured is displacement. Okay, displacement means that the distance between one point to another point, okay, or you want to measure force value. Okay, so you need first, when you look at this type of data sheet, okay, data sheet is given to you, but assuming that you're given a problem, okay, a problem, and then you need to determine what type of sensor is being used, okay, and first of all is that you need to know what type of output you need to measure. So you have learned that I have explained last week is that there are multiple measure. The common one is displacement, the force, temperature, okay, level sensor. So those type of output that you can measure, and level sensor and displacement sensor is almost the same because it actually measure distance. So based on that, okay, student, when they have that problem, then they need to find out what type of sensor they use. So this is where you will normally find out what are the data sheet. Okay, data sheet, you need to purchase something. For example, infrared sensor shown here. Okay, so you find out what are the types of infrared sensor that is available in the market, and basically you need to look at the main point is that the price, cost price. You don't want to have it very expensive, but it need to be affordable. Okay, so affordable means that for the final year project, normally price is about the total that student can claim is 200 ringgit. So those are things that student need to take note. Sekejap, I open mic, ada orang open mic. Okay, so those okay. So basically, based on that sensor is that what task exercise 1 was about is that to determine the accuracy, the resolution, right? So you did all of that, and this are all of the application where you can use that sensor. Okay, so I saw that lots of students, actually lots of the group actually did well on that. Okay, so I'm going to skip that. So basically, you know how to actually select sensor. Okay, infrared sensor are many type sensor based on the model type. So for example, like Infineon, they come up with different sensor, IR sensor. ST, they come up with different sensor. ST micro, different sensor. For example, this is an instrument, different IR sensor. So they have their own model. That's where you see that there's a laser printed on the chip, so you know which company produced it. And exercise 2 was basically to determine you're given the different types of output, force, displacement, and you need to find out what are the available type of sensor to measure displacement. So the exercise was for you to have an option. Okay, option. If you were to measure displacement, okay, so what are the options that you have? So example of option that you have, of course, in the exercises that I asked list out two only. Okay, if you are good enough, the group is good enough, you can list out up to 5. Okay, so example of displacement sensor that student can choose is capacitance sensor to measure displacement. You can use ultrasonic sensor. Okay, you can use IR sensor for displacement. You can use also laser sensor. So different types of sensor, okay, to measure displacement. Category of sensor. Okay, so and what I mean by category of sensor is that principle to measure it is different. Okay, so this is what you have learned in exercise number 2. In exercise number 3 is that, okay, you were given case study. Okay, you were given a case study, and basically 10 case study. So based on that case study, okay, even though in the case study it doesn't ask, it doesn't explain to you what type of output you measure, but from the video you should be able to determine what are the measured output. Okay, what are the things that you control. When you want to control something, okay, you want to control displacement, you want to control the angle, okay, so you know that you need to have this sensor. So this is where students need to discuss with their peers. Okay, so let me just show you an example where the exercise 3 is directly will be related to your assignment. Okay, later on. Okay. Okay, this one. Okay, so if you look at this example, this is an example of case study that was given the final exam last semester, last 2 semester. Okay, so well, we have total of more than 10 sets of data. So let's just look at this case study. So a rehabilitation clinic requests company robot to develop a wearable automated lower limb rehabilitation system. Below waist means that below waist and below you have post-stroke patient to recover from injury or neurological condition. Figure below shows example of physio session that patient need to perform using display. The aim is to achieve repetitive bending. Okay, so if you notice that this is one of the video that I asked one of the group student to determine what type of sensor. So, well, in final exam, I'm going to give statement like this. Okay, this is the problem. What are the things that need to be measured? So, the wearable, this is the requirement from the company. And the wearable automated volume must include the following requirement and specification. Okay, so the system that you need to build need to have this requirement. Patient will wear the mechanism in the face and operate in the sitting position with extension beating. Okay, so the knee need to be extended. The wearable system must be lightweight. Okay, the wearable system must be lightweight. Number 3 is that use a mechanism that able to convert from linear to rotary motion. Okay, so later I will explain. Okay, next is that rehabilitation for knee joint, bending maximum at 90 degrees. So if you look at some of this statement, it is combination of multiple chapters. So if you look at this requirement, let's look at this one. Okay, patient will wear the mechanism in face. So basically, a student later on will need to sketch how does the mechanism look like. Okay. In contrast, this is where it's related to exercise number 3. Okay, exercise number 3 is that you're given a video, so you already know how does it look like. So you need to determine the sensor. Okay, so wearable system must be lightweight. So means that for this case that you need to know that it's going to be actually wear at the feet. Second one is that lightweight. So you need to determine the material. Material must be lightweight. So it cannot be metal. Okay. Use mechanism that able to convert from linear motion. So this is where later on you will learn in chapter 6, which is on mechanism, a mechanical actuator. So mechanism will be learned, and this is where you need to determine what type of mechanism can be used in this system. The next one is that rehabilitation for knee bending maximum adaptability. So if you look at this is where you need to determine what type of sensor need to be used. Okay? Is it that you're going to purchase a displacement sensor that can measure distance? Okay? But you're going to actually measure bending, motion, and angle. So are you going to buy a sensor that can read rotation, or a sensor that can actually measure a displacement? So there are two things. So the sensor that can measure linear motion or rotation. So this is two different types of sensor. Okay, but of course you can actually see here is that it says here is that the mechanism able to convert from linear to rotary motion. So this is so you can either use this sensor, sensor that can measure linear motion, and then you're going to use the mechanism to actually convert the linear angle to rotary motion. So this is where you need to have a few equations, mathematical equation. Require a closed loop system to control the speed of mechanism at 0.15. This one is another sensor. Why? Because you want to measure the speed. Okay, so another sensor. So you have one sensor, okay, full load up to 20 kilogram. So when you have this full load at 20 kilogram, meaning that the sensor can actually measure up to 20 kilogram. Okay, so do you think that you need a sensor here to measure a force? So this is where a student need to determine what are the type of sensor. So if you look at the question for this question is that, okay, so the first of all is that, okay, the question is that identify these 5 functions required to execute the process. Okay, the process to measure the displacement. Okay, so what is the process? So what are the functions? What are the flow and description? Okay, so this one, for this explanation of identify this 5 function here, okay, I would please refer to my notes that I have loaded in chapter 3 here, which is this one, chapter 1, Bolton reference student. So this one is explaining about the flow chart just now. Okay, the flow, what type of description and flow. Okay. If student download this and you will read through, this is from the textbook. As mentioned, for this, student need to have the referring to the textbook. So this is Bolton textbook. So you can see that the concept of generation flow, classes, and flow types. So we have the energy flow from human, hydraulic, or mechanical. So all of these are energy. And material, what are the material in between? So if you have a hydraulic, then the material is, for example, if you have a hydraulic, then the material will be liquid. Okay, and the signal can be either you can actually sense what you want to control over there. So you might want to sense the tactile, okay, sensory. So these are the things that if you look at this part is that you will end up having a open loop block diagram. So just go through these notes later on, and you can see that how it they come up with the open loop. It's you have the energy from here, electrical energy, then you're going to convert it to rotational energy. Okay, so all of this is that it explains how you can use this component and make it structural type blocks for a system. So read through. Okay, it's very detailed in this book, so you can read through, and after reading through this document, then you will able to actually understand what is the flow. Okay, so that one is student task for today and tomorrow. tomorrow because we don't have class, but you can do the self-assessment on your own. So so basically, what we did for SSS 3, okay? So I would like one student from each group to present. So let's look at this group 4. Any of the member 4 over here?
Yes, doctor.
Okay, can you share your screen? You don't need to open at the Padlet. You have the original file, right? So just share your screen and open that. And so what I want you to do is that basically similar what I explained just now. Okay? From the video, explain first what are the output being measured. And explain why you select sensor. Okay, as per the assignment. So why you select sensor. Okay. Then how many sensor do you think is required for the task? Then where is the base application? So basically you need to sketch the drawing. Okay, so let's start. Group number, I think we can start from top 1 here. Group number 4. Who's going to present?
So I share my screen.
Chu, Okay. FYI, for student, I'm going to take note on student who presenting. Okay, this means that all students need to present later on. So those who already present, they can skip if they are in the same group. So other students need to present. So Chu, Chuzi how? Right, Chu?
See my screen?
Yeah, okay, can see. Okay, boleh proceed. You can proceed.
To all, I'd like to produce my exercise 3. Our project is the robotic hand.
Oh, robotic hand with the wires.
Yes.
Okay, alright.
The best sensor that for our task we choose is the flex sensor. Of flex sensor. A flex sensor or bend sensor.
Before that, did you only pick only one sensor or did you give out an option? I think, well, of course, the assignment say the best sensor, right? But but you should have listed 3 sensor and come up with the best option. Similar, is continued from exercise 2. Exercise 2 is that, in exercise 2, you list out a few options for the types of output.
Yeah.
So for your group 4, did you list out several sensor or only flex sensor?
We only one only.
Oh my god, okay. Because the answer is wrong. Because
I see that the video they only use the servo motor to push up the hand.
Yes. That's why you need to find out why they are using servo motor. And they are not using flex sensor.
No, the servo motor we also have choose, but that one is we thought that that is not a sensor, so we don't have put inside the best sensor.
Okay, so are you going to present that servo motor?
Yeah.
Okay, alright. So present first. But I will later tell you which one is the correct sensor. Okay. Reason why it's not. For example, if you choose flex sensor, so I will determine if it's good or not and why. So okay, continue, Chu.
The
no. Back. You need to explain first.
Sorry, doctor. I'm not clear, doctor. Of course.
You present just now. This is what slide? Okay, for all student, okay, normally slide kena ada slide number I don't know which slide is this. Slide number kena masuk, insertkan slide number. Okay, back again. I'm not sure which page is this. First slide. First slide. Okay, second slide. Okay, alright. I think, okay, next. Okay, tak apalah. Next. First time kan. I think I will comment on the presentation. Next. This one. Explain this one. You skip this one, right? You cannot skip because everybody here maybe it's the first time, so you need to explain. Explain.
The definition of flex sensor. Flex sensor or bend sensor is a sensor that measures the amount of deflection or bending. Usually the sensor is stuck to the surface or resistance of sensor element is varied by bending the surface. Since the resistance is directly proportional to the amount of bend, it is used as denominator and often called flexible potentiometer.
Okay, wait. Okay, I'm going to comment. Slide Okay, this for our student take. Right? Okay, during classes, I will normally commented on student style of presentation. Okay, the PowerPoint that is prepared, so that for me, when I comment is that this one be directly commenting on how you prepare your slide for final year project. Okay, so take note Take note means that jot down lah. Okay, normally in the slide, don't put paragraph like this. Okay, one paragraph paste dump it in one slide. Okay, one thing is that when you have this type of paragraph, what you did just now was the tendency is to skip slide because you assume that everybody can read it. Okay, but I'm not saying you. This is the group 4. So group 4. Next time when you prepare slide should be in point 4. If you see my slide, it's paragraph like this in one slide. It's boring, okay? And the tendency is that student won't actually listen to my class. So how you prepare the slide is that point key. So just come out, for example, for this slide, key point is that measure deflection or bending. That is the key point. So the rest is that you elaborate it, explain it. Okay, like you explain. So it would be boring. So people will listen to you, your explanation. Okay? So point 4 is that just now the slide number. Okay, because right now I do not know what slide number you are at. For example, I have to look at the previous slide. So what is the previous slide number? So I might want to look at slide 1. Show what number is it. Okay, so slide number need to be slide. Okay, of course, in the template, normally slide number is not there. Make it a habit to insert the slide number inside each slide. Okay, make it a habit. Okay. Explain sensor number 3. Comment is that when you explain flex sensor, this is the that fundamental is that it is resistance of sensor element vary based on bending surface. So it means that if you have a larger displacement, then you have a larger resistance. Okay, so I would explain this slide.
Doctor, I can't hear doctor voice. So here.
Not here. Yeah, the rest of student.
Dia macam sangkut-sangkut sikit.
Ha.
Sangkut. Okay, tak apalah, sangkut. Hopefully, well, tak apalah. We assume that sangkut-sangkut banyak ke sangkut sikit je tadi? Ke dari tadi, I cakap 1 minit tu dah, 1 minit I bercakap tu, you you tak cakap apa-apa ke?
Ada dengar tak dengar.
Next time ni lagi satu. remote teaching ni, saya tak tahu student punya muka tak nampak. I do not know student listen ada masalah internet ke apa. Okay, but I'm not sure. Okay, but macam mana nak repeat balik ke? Now, is it still apa? Masih, is it still not clear?
Ada tak ada juga.
Clear juga. Testing sekarang ni? Tak, clear tak? Tapi mungkin ada bunyi bunyi kipas ni.
Boleh.
Clear tak?
Dengar.
Atau pada tersangkut-sangkut?
Ada sangkut.
Tersangkut juga? Pagi, kalau internet pagi ni dengan cuti macam ni. Okay, testing 1, 2, 3. Testing 1, 2, 3. Dengar tak 1, 2, 3 nya?
Dengar.
Sangkut lagi ke?
Tak ada.
So, nombor 1, just now, number 1 is about, just directly key point. Number 1 is about preparing the slide must be key point. Second one is that if you are explaining about the fundamental, the principle of resistance using sensor element. So, if possible, in the slide is that you need to have some figure or diagram that explain it. Kan macam ni saja. So, definition of flex sensor, you show lah Chu punya slide that explaining what flex sensor is. I'm not sure. Okay, so next, Chu.
Next will be the objective of flex sensor or the function of flex sensor. The flex sensor is used to measure the amount of deflection or bending. The internal resistance of the sensor directly proportional with the angle of its flex. Next will be the how many sensors are required for each touch.
So I already the answer. You didn't explain about servo motor. Servo motor is a servo motor. Okay. I think last week class servo motor normally they have an encoder to measure a sense, measure displacement. Remember?
Yes.
Servo motor. So it should be explaining about flex sensor. You need to explain about encoder. It's not, you cannot use the servo motor. Servo motor is actually, it's not a sensor.
To be assign the best location to move the sensor and explain your reason. This is the front view of our robotic hand.
So where is the flex sensor?
Servo motor. And this will be the flex sensor. This for.
Does a flex sensor look like?
Dia sepatang macam tu. Lepas tu.
So, the question is how do you set the flex sensor to the robot system?
I tengok kat internet dia macam dia lekat kat robotic hand punya tapak.
So right now, how do you connect it? You see that it's
Ya. Ni protect
sensor tu.
Ni flex sensor sebab kalau dekat kat front view dia nampak macam tu je. Kalau dekat kat tapak belakang tangan robotic hand tu.
So I think there's confusion on that sensor. Okay. Number next. So that is the. So what do you think the servo motor? So servo is it actuated? Because you see that you should just now the type of sensor that can be used is sensor is a motor and flex sensor, right? So
Yeah.
you think so are you saying that servo motor is a sensor?
No.
So how do you list it? The so just now
Sorry, Doctor. I
how is that in your option of sensor just now?
first because we thought that the first question is choosing the best sensor, and the second question is list out all the material that we have used as a sensor like that.
So the material used for sensor is flex sensor, right? Because it's
Yeah.
built flex sensor. So
Yes.
servo motor is not sensor. Servo motor
Yes.
is actuator.
Side view. This will be the side view of the.
It's the flex sensor. One more thing, commented there. I will comment here. Okay, the diagram is good. You draw out the sketch. Just label, faham tak label? Buat arrow, labelkan ke mana flex sensor tu. Baru I tahu itu flex sensor. So right now, if I look at your sketch,
Dia ada sebab 5 tangan kan, dia ada setiap finger dia ada satu top view.
okay, good. See, because you were given the video, given the video just now, so you might not see what sensor is being used. So okay, it's okay. I'm going to download two example. Maybe today we cannot actually discuss one first. So just download that first. This is a very good example for discussion. So I'm going to share to my screen. You can see it. So this one is choose. So okay. Then says just look at video. Student maybe saw the video. So from this simple video, basically, if you look at the video, so okay, so do this type of assignment later, for example in chapter 6 on the types of actuator, types of mechanism. So based on the case study is that the best sensor is the one best sensor to select. But I would suggest that list out 5 types of sensor. So 5 types of sensor to measure rotation. And from these 5 sensor is that select only one is the best. Okay, so this is how we are going to do positioning. So basically, this select the first one is only flex sensor. Sure, why you didn't actually list out sensor? Because if you look at the case study, the objective is to measure rotation. So this is what I explained just now. Okay, what to be measured? Output to be measured. So you want to measure rotation for different type of actuator, for different system. You want to measure displacement. So when we talk displacement, it normally should be linear. Linear ni maksudnya, okay, rotation is like this. Rotation. So linear is that you want to measure a linear displacement. Okay. So from this case study, you need to find the type of sensor that can measure radiation. So one of it, sure there are other type sensor that can measure rotation. Example that I just explained to you just now was encoder. So we have first one is flex sensor, second one is encoder. So what the hell is encoder? Encoder is displacement. So it be very accurate. It's directly connected. So for group 3 and for group 4, I would suggest, okay, this one is okay. Just that find out 2 more sensors. Okay, total find 3 sensors that can measure rotation. Okay, so 2 and your group lah, the rest of the group, can you find out 2 more sensors that can measure rotation? Okay, so this is and so normally the task case study that we give to students is that student need to make a correction. Okay, means that if I were to give marks to this group, okay, 10, give only, okay, because of the selection of sensor, it's not accurate, okay, and because flat sensor, I do not say that flat sensor is the best sensor to be used for precision, because it does not have precision. So you see that in the beginning of the sensor and transducer chapter is that we explain about terminology. Okay, what you want to look for is the accuracy. Okay, selection of sensor is that you need to find out what are the accuracy of that sensor, the accuracy of the encoder. So basically, okay, what students need to do when they do select the best sensors first, okay, select 3 types of sensor. Just second is that refer to data sheet. Sheet terminology that you have the exercise. You need to compare why you choose example, cat sensor is the best. Basically, based on this reference, sensor 1, 2, and 3. So what are the so of course you are going to select best sensor based on the advantage. Ada banyak lagi bagus, so you are going to choose that type of sensor. So basically, as student, okay, to do that. So this is how you should do it. So analyze the selection of suitable mechanism requirements. So basically for chapter 2 just now, the selection of the best sensor to perform each function, perform the output or the measurement. So what are the function? So you are going to measure the. So what is the option sensor number 1? Reason why? What is the fundamental there? Principle. Option 2, option 3. Then you are going to justify why you choose option number 1 as the sensor. So this is not only to number 4, okay, but to all the group. So look back at your assignment. Not sure for the rest of the say just look at okay, so this one, okay, the student, okay, this group 9 did okay. So they list out 9 type of three type of sensor: velocity sensor, acceleration sensor, and displacement sensor. Okay, and then they explain what is the advantage of sensor. Okay, what are the requirement basically. So but that's good. So they explain a little bit about the passive cortical sensor system. So where should all the sensor be? Okay, location of the sensor. Okay, explain a bit about the displacement sensor. Okay, so very good. I think this group did better version of that. So for group 4, if I were to give marks, I think I will give you 6 out of 10. 4/10, because they list out the 3 type of sensor just now. So I will give them sensor, but there is no specific sensor over here. Sensor they use. So I'm going to give them 6. Okay. So basically, need to improve on that. Okay, so I hope that all the students here show how many students here. Okay, the rest were really good. Okay, the 10 students. So you're going to actually do again. Just do the correction of yourself. Okay. The original slide here, okay, the original submission here, no need to actually delete it. But with 3, so our here is a correction, correction exercise 3, So correction for exercise 3 means that even though I commented only on group, the rest of the students back again assignment that you submit, be sure it's not 100% marks if I want to check it again. So go through it again. Please select 3 types of sensor. Measure the output. The output, it can be measure displacement based on the distance. Based on that, so this is where you see in all exercises. Exercise 1 is on the terminology, characteristic, specification of sensor. Exercise 2 is on the exercise 2 was on the types of sensor measure. Okay? So exercise 3 is direct on the application. So this is where I mentioned to you all. Okay, in order for you to do exercise 3, you need to complete exercise 1 and exercise 1. Exercise 3 is no good. From exercise 3, what I see is that the student come out with the slides that you is referring at exercise done, exercise 1 and 2. Okay, you're just wasting your time actually. I'll give you data sheet, ask you to come up with the accuracy and so on. That is the knowledge that you should exercise 3. Similarly, exercise 2 also you should actually adopt that knowledge. Actually, Dr. Mariam asked you to use sensor to measure displacement, to measure rotation. It's a reason because it is required for you. That knowledge is required for exercise 3. So, sorry, something internet, so I off the video so that it's much more smooth. So I think that will be all for today class. So I hope that time to actually check again submission for exercise 3, and then don't forget okay, I already opened the self-assessment test quiz and self-assessment quiz for chapter 2, so try to do that. If you get marks lower than half marks so redo the quiz. So should be you could get more than half more than half. Okay, if you want to score for this midterm exam, okay, midterm exam will cover this chapter also. Okay, and don't forget to open the submission for this week is it open yet? Open it by tomorrow for this for the feedback form. Okay, so after this class I will open it and maybe I will extend it until okay, so from student before we end the class. So tomorrow we don't have class, but you need to just a synchronized study using the ULEARN instruction. Any question?
No, Doctor.
This 10 student, you are going to stay with the class, 10 student?
9. 9.
Sorry, 9. Confirm, Okay, so confirm, okay, it's okay. So, to the faculty section on the family also require me to actually make a checking. So basically, section 2 will same start. So student from section 1 so we will still proceed with the class given. So this week, tomorrow no class, but you need to make this one and also section 3 is on your case study. Okay, so it's okay if you are only in one satu saja. Here, you're only left with you alone.
Saya.
Syafiq,
Sihat.
ada yang Chu,
Ya.
Saya.
Ya, doktor saya.
Saya juga.
sebelum tinggal satu. Because you already done it, so take it as it's like a challenge lah, because they want to submit for this final so you need to 5 cents. So don't worry. So I will give you until next week lah, 1 week to actually read sentence 3 and you submit it. Okay, so take the time to actually read it. So that will be all from me.
Okay, Doctor.
Doktor. Nak tanya. Yang suggestion tu, sensor tu, yang doktor nak maksimum berapa? Minimum berapa? Minimum 3. Okay.
Lebih 3 lagi bagus lah sebab ada more option. And for your information in a final exam sometimes even though we ask the minimum is 3, but the answer that student give is wrong. So because the suggestion is wrong. So if it's best if student can give more than. So if you give 5, 3 is good. So you get full mark. Okay. So the wrong answer you won't give marks based on the answer, the good answer. Okay. So so if in question saying that okay, sensor each measurement output. So suggest if more than 3. Okay. If you don't want your marks to be all.
Lepas yang kita pilih tu, kita kena terang lah. Yang satu-satu, 3. Oh.
Because now it's 7. So just miss out the type of sensor. If you change it or you can Google the answer. Google what are displacement sensor, and then you come out and then list it in your answer. Okay? Nanti final exam 3 students. 3 students. Sensor, it doesn't represent the marks. Final exam, this question, one question is 25 marks. By listing the name of the sensor, you are cuma dapat 1 mark dia. Okay? So, itu je lah dia. So, if you look at the marks, mesti besar. Student need to explain each instance then get marks. So, some tips. Because a lot of students saja because they exam just so markah cukup je pasal explanation of principle strings sensor ada so berarti ke 12 lah tu tak termasuk lagi sketching just now sensor where is the location, then label it clearly. Label also have marks. So sensor. Question?
Can doctor share doctor can share the partial question inside the you learn.
I will share later on. To give it like one sum, because I feel the student will feel overwhelmed, like so many case study to do it. So I'm going to give it from time to time. For example, just now one case study, Q. So one case study is actually reflecting to the case study. Basically, the case study of rehabilitation just now was in one of the video. I share again. The video, Class after this? No class, Class, If you have class, then I will finish it earlier. Okay, this one, lower limb rehabilitation. So, basically,
Greetings, everyone.
Basically, the example that I'll give to you in the point just now, the case study is from this student.
Firstly, the pressure and return on
So you
controller
can go
box
through it,
of the
look
slider
at
and
it.
crank on S.
So in this video, you can directly, he explained it. So you already get the hint what is answer. Sensor is using, what type of mechanism is using. So suggest even though you get the answer case study session 4, go go through all of the video. Okay. So, Ju, later on, from time to time, I will share to you example of past year, and for the past year just now, share. Ju, Syafiq, selalu bercakap ni, 3 orang ni, Vivian, okay, Jing, Izul, Arifah, Tan, Shini.
Okay.
That will be all for my class today. So, pick the task. Feedback, I will try to make it available by today. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye. Take care.
Salam.
Thank you, doctor.